Good morning, students. Today we shall discuss about one important contact force, that is frictional force. Let us say an object of mass m is kept. An object of mass m is kept on a table surface. On the table surface. The body is at rest. When you keep any object on the table like a duster or a book, it is at rest. It means the weight of this body is balanced by the normal force. Weight of the body, if you call this one as weight, which is equal to m into g, this is balanced by the normal force which is acting vertically upwards. Weight of the body is balanced by vertical normal force. It is denoted by m. Now suppose that you have applied some parallel force. This is the applied force. Applied external force. For a small amount of force, for example, suppose you are pushing desk. If the amount of force is less, the desk doesn't move at all. Then slowly you go on increasing the force. Still then the desk doesn't move. Then you apply large amount of force, then the desk starts moving. Means for small applied force, the block or the object does not move. There must be some opposing force. That opposing force will be exerted along the surfaces in the opposite direction. This is what we call as the frictional force. The frictional force is the force which opposes the motion of an object and which exists between the two surfaces which are in contact. For example, this is the block. The surface of this block is in contact with table surface. So there is an opposing force which opposes the motion of the object. The motion of the object would be in this direction. The motion of the object would be in this direction, and the opposing force to the motion, that is what we call as friction, will be opposite to the motion of the object. This is what we call as friction. Now, there are three types of friction. One is called static friction. Second one is called kinetic friction. Kinetic friction. The third one is called rolling friction. These are the three types of friction. These are contact forces. Okay. Now let us study first the static friction. What is the meaning of static friction? Let us take example of cupboard. When the cupboard is filled with your textbooks, your trunk, everything, if you try to move the cupboard hardly moves. It doesn't move at all. Then you will apply still larger force. Still then it will not move. Still you will apply larger force. Then you will call your friends, one or two friends. Then all three together you will push it. Then slowly the cupboard moves. Means when you apply a small amount of force, the object doesn't move. The object still is at rest. So this type of force which is opposing the impending motion, the force which opposes the impending motion of the object is called as static friction. What is the meaning of impending motion? If the surface is having zero friction, means if the surface is very smooth enough, then we know from Newton's second law, the moment you apply force, the object should move and get accelerated. We know that force is equal to m into A. If there is no opposite force, the moment you apply force, the object should undergo motion and it should accelerate with acceleration A. But since there is opposing force, the body is not set into motion immediately. So, if the friction would not be there, the body would continue to move by any amount of applied force, and the motion, the accelerated motion, will be proportional to the applied force according to Newton's second law. But since there is an opposing force which is exerted between the two surfaces in contact, that force is called as frictional force. Now, this static friction is the force of opposition or the opposing force which resists the motion of object and which is exerted between the two surfaces in contact when the body is still at rest. The moment the body starts moving, like the cupboard, I gave example of cupboard. The moment the cupboard starts moving, that moment you need not apply that much of high amount of force. Then we say that cupboard is sliding or the desk is sliding. When the sliding starts taking place, that moment whatever the friction comes into play, we call it as kinetic friction. We call that friction as kinetic friction, or you can call kinetic friction. So when the two bodies are in actual motion, one over the another, sliding motion, the force of opposition to the surfaces in contact when they are sliding one over the another, it is called as kinetic friction. The rolling friction comes into play whenever the body is fitted with the wheels. Nowadays you are carrying the luggage with wheels, the bag with wheels, suitcase with wheels. It's very easy to roll. Any amount of luggage you put it inside, or the load you put it, whatever the load it is, but still you can very easily roll it. The rolling friction is minimum because of the rolling of wheels. So whenever the rolling of bodies take place on the surfaces with the help of wheels, the friction that comes into play when the rolling takes place, it is called as rolling friction. Now, what is the meaning of static friction? You just write it. The force which opposes the impending motion of the object is called static friction. It is the type of friction. It is denoted by Fs. The prefix S denotes static friction. Small f s. Then how is this static friction? If you draw a graph of friction against applied force. As you go on applying small amount of force, initially when no force is applied, object is at rest. As you go on increasing the applied force gradually, the static friction also increases. Still you push it with little more force, object is still at rest. So the static friction is directly proportional to applied force. If you draw a graph, the graph comes out to be linear graph. At one large amount of force, then what happens? The body is set into motion. The body starts moving. Then at that moment, the body is sliding. When the body is sliding, when the body starts actual motion, that moment the friction that comes into play will be less than static friction. It will be almost constant. So this part of friction we call it as static friction, and this part of the friction we call it as kinetic friction, and this is the peak value, maximum value we call it as limiting value of static friction or maximum value of static friction, Fs max. Fs max, maximum value of static friction, means for small amount of force, applied force, the object hardly moves. As you go on increasing the applied force, still the body is at rest. As you increase the applied force, at one particular applied force, the body is just set into motion. That maximum amount of the force, the maximum amount of applied force, above which the body is just set into motion, we call it as maximum static friction. So I will define what is Fs max. Fs max is also called as limiting value of static friction. Limiting value of static friction. So from this graph it is evident that the static friction is directly proportional to applied force until it reaches that required maximum value. Once you apply the force greater than the maximum value, the body is just set into sliding motion. So that value of maximum static friction we call it as Fs max or limiting value of static friction. So we can now define what is limiting value of static friction. The maximum value of static friction or applied force above which the body just starts moving or sliding, just starts sliding or moving, is called limiting value of static friction. Limiting value of static friction, which is denoted by, as I have written already, Fs max. For all other values of static friction, the body doesn't move, the body is still at rest. For all other lower values of applied force, the static friction is exerted such that the body is still in static condition, the body is still stationary, the body is still at rest. Now based on that, there are two laws. They are called as laws of static friction. Now we will learn laws of static friction. Okay, I think you understood what is the meaning of impending motion. Impending motion would be the motion that would be present in the body if there would be no friction. As I told you earlier, if the surface is very smooth enough, just a small push is enough for the body to be set into motion. So the motion that would be present in case no friction is there between the surfaces, it is called as impending motion. But naturally, if you observe any surface if you take, it will be always exerting opposing force. The friction will be always there. So impending motion is the motion that would not be there exactly. So the impending motion is the motion of the object when there will be no friction. So the friction which opposes this impending motion of the body is called as static friction. Now let us write the laws of static friction. It is regarding the nature of this static friction. It is found that the static friction, if you denote it by Fs, yes, this static friction is found to be directly proportional to the normal force. The static friction is found to be directly proportional to normal force. To understand this, normal force is exactly equal to weight of the body. More the weight of the body, more is the normal force. More the normal force, more is the static friction. I gave you example of cupboard. For example, if the cupboard is empty, it's very easy to move the cupboard. You have experience, you have got the experience. If the cupboard is empty, you can very easily push the cupboard, empty cupboard. So static friction would be less. If the cupboard is filled with books, trunk and all the luggages, and if you try to push that cupboard, then its weight will be more. More the weight, more will be the normal force. More the normal force, more is the static friction. So the first law is about the static friction. The limiting value of static friction is directly proportional to normal force, or it is also called as normal reaction. So mathematically, if you write Fs max is directly proportional to M. If you take out this proportionality sign, then it becomes Fs max is equal to Ms M, where Ms is proportionality constant, which depends on the nature of surface. Nature of surface means how rough is the surface, how smooth is the surface. If the surface is very smooth enough, very neatly polished, cleaned floor, then Ms value will be less. If the surface is rough, like the quadrangle, the tar surface, road surface, rough surface, then it's very difficult to slide any object. Then this Ms value will be large. So Ms is called as coefficient of static friction, where Ms is called coefficient of static friction. Second one, regarding the limiting value of static friction, which we denoted as Fs max. This Fs max is independent of surface area. Independent means it does not depend. Independent of area in contact means whether it is larger surface area in contact or smaller surface area in contact, this Fs max does not depend on the amount of surface area in contact. I think you got it. Fs max does not depend. Independent means does not depend on area in contact, amount of area in contact. The third one is regarding the coefficient of static friction. Ms, coefficient of static friction, depends on the nature of surfaces. The nature of these surfaces, you see, this is table surface and this is the surface of the block. The nature of those surfaces. Coefficient of static friction depends on the nature of surfaces in contact. Nature of surfaces means how much it is rough, roughness, or It depends on roughness or smoothness. Roughness or smoothness. So this is how we study the laws of static friction. These laws of static frictions are obtained from experimental observations. These are just empirical laws, not exact laws like Newton's law of gravitation, Coulomb's law of electrostatic force, and magnetic force, the laws of magnetic force. No, they are exact laws, laws of gravitation and all. These are empirical laws. Empirical laws means these are just experimentally observed, and these are helpful for calculations. Okay, I think you got the meaning of empirical laws. Okay, then you can define what is coefficient of static friction. Coefficient of static friction can be defined. I will define it here itself. Mus is equal to Fs max divided by N. If you just take this N this side, Fs max divided by N gives us Mus. So coefficient of static friction is defined as the ratio of limiting value of static friction, coefficient of, okay, the ratio of limiting value of static friction to the normal reaction, to the normal force. Normal force or normal reaction is called coefficient of static friction, Mus. For smooth surfaces, Mus values are less, low values. For rough surfaces, very rough surfaces, the Mus value is high. That is the meaning of coefficient of static friction, and its dependence. It depends on the area of nature of surface. It does not depend on area. It depends on nature of surfaces, how rough it is, how smooth it is. Now we will learn something about kinetic friction. Okay, once again we will see when the applied force here is okay. When the body is at rest, still body is at rest, then that force which opposes the impending motion is called as static friction. Once the applied force reaches this maximum value, Fs max, beyond that, suddenly the body is set into motion. When the body is set into motion, the friction that comes into play, which opposes the sliding motion, the friction that comes into play, which opposes the body in motion, means which opposes the sliding motion of the surfaces in contact, that friction is called as kinetic friction. So we can define kinetic friction as the force which opposes the sliding motion of the surfaces. So in general, sliding motion of the surfaces, in another term I can write as relative motion of the surfaces. Relative motion of the surfaces in contact with each other. In contact with each other is called kinetic friction. And with our experience, we come to know that this kinetic friction Fk, the prefix K, denotes kinetic friction Fk. This kinetic friction is found to be always less than Fs max. It is less than the limiting value of static friction, which is evident from the graph also, which is less than static friction. So once the body is sliding, then what happens? That force of opposition comes into play, is called as kinetic friction, which is less than maximum value of static friction or limiting value of static friction. Now, the body is now in motion. You can see from the diagram. Earlier, body was still at rest. Now, the body is already in motion. So, when the body is in motion, these surfaces are in contact and they are rubbing over each other. When the surfaces are rubbing over each other, the force of opposition which comes into play, which opposes the relative motion of the surfaces in contact, is called as kinetic friction. Now, again, we can list laws of kinetic friction. Laws of kinetic friction. These are also similar laws. The first one, Fk, kinetic friction, is directly proportional to the normal force again. Just like what we wrote there, same equation. Fk is directly proportional to normal reaction. Greater the weight, more is the normal reaction. More the normal reaction, more is the kinetic friction. So if you take out this proportional sign, then Fk becomes equal to mu Kn. So this mu K is now called as coefficient of kinetic friction, where Uk is called coefficient of kinetic friction or kinetic friction. You can define coefficient of kinetic friction in the same way how we defined earlier. It is defined as the ratio of Uk is defined as the ratio of kinetic friction to the normal reaction. From this equation, Uk is equal to Fk by N. So ratio of kinetic friction to the normal force, or it is also called as reaction, normal reaction force or normal force. This is how we define the coefficient of kinetic friction. Now again, this coefficient of kinetic friction does not depend on the area of surfaces. That is second one. Coefficient of kinetic friction or kinetic friction does not depend on area of surfaces in contact. Just similar, it does not depend on the area of surfaces in contact. Then, when we say the body is in motion, then we come across the speed of the body. How about the kinetic friction depending on speed of the body? The kinetic friction does not depend on speed of the body. Third one, Fk does not depend on V, speed of the or velocity of the body. Then the last one, again, mu K depends on the nature of surfaces. Mu K, that is coefficient of kinetic friction, depends on the nature of surfaces in contact. I told you what is nature of surfaces. How smooth is the surface? How rough is the surface? So that's how the coefficient of static friction depends on nature of surfaces. As I told you earlier, here also mu K is taking low values for smooth surfaces and mu K takes high values for rough surfaces. And experimentally it is observed that mu K is always less than observed fact. Coefficient of kinetic friction is less than coefficient of static friction. So this is how we study the laws of kinetic friction. Now, if a surface is having certain amount of mu k, means it is having certain roughness, so it shows definitely kinetic friction. So, if at all you want to find out the acceleration, now suppose the body is already set into motion, the body undergoes acceleration A in this direction, and this is the applied force F. Then according to Newton's second law, we know that F is equal to ma. But here the net force is not F. The net force we need to calculate. Then the acceleration depends on the net force F minus Fk. See, this is a kinetic friction in the opposing direction. So if you write the equation for Newton's second law, when there exists a kinetic friction, Newton's second law now gets modified in this way. F minus Fk, F minus Fk becomes equal to m into a, where a is the acceleration. Thus now acceleration can be calculated as F minus Fk divided by m. If suppose the mass of the body is 2 kg, mass of the body is 2 kg and applied force is 20 Newton. If m is equal to 2 kg and applied force is 20 Newton, right? Then suppose Fk is 2 Newton. Then you can calculate what is acceleration. In this case, the acceleration now becomes, in this example, acceleration now becomes 20 minus opposing force. This is 20, this is minus 2. 20 minus 2 divided by 2. 20 minus 2 divided by 2 kg. That becomes 18 by 2. So it becomes 9 meter per second square. If the surface would not be having any friction, if the surface would be smooth enough, if it is a frictionless surface, then Fk would be 0. In that case, if Fk is 0, then what happens? F is equal to ma. Then acceleration would be 20 by 2. Acceleration would be 20 by 2, then it would be 10 meter per second square. 10 meter per second square. I think you got the point. Now once the body is set into motion, now if you remove the external force, the body is already set into motion, you have pushed the body, now body is set into motion, now you have not applied any force. Then what happens? If external force is absent, then what happens to acceleration? In absence of external force, the acceleration now becomes a equal to minus Fk by m. So minus sign shows that the body is going to retard. Ultimately, it is going to stop after some distance. Ultimately, it is going to stop. For example, whenever you push any object or roll any body, after some distance it stops because it undergoes retardation. That is the meaning of the friction. So we will learn more about friction in the next session, that is rolling friction, and then we will study certain numerical examples. Okay, I think you got the point. So remember, Fk is directly proportional to normal reaction, and Fk does not depend on area of surfaces in contact. Fk depends on the nature of the surfaces in contact. Mu k is less than mus, and Fk does not depend on speed of the body. Speed of the body, whether the speed is large, whether the speed is more or less, Fk takes the same value because it is the force of friction exerted between the two surfaces which are sliding one over the other. Depends on the only nature of the surfaces, not the speed of the objects. Okay. Thank you. Have a nice day. Good day.